Welcome back to the morning show. Our wise guy brought a whole carton of eggs with him. What are you doing today?
Well, I have fewer eggs now than I did a little while ago. I had this egg without a shell on it, which I'll have to do again next week. And I was playing with it because I wanted to show how it was rubbery for the bump shot, and then it broke all over the place. So,
raw egg, not a hard-boiled one.
Right. And so, yeah, so the key to this, actually, we're going to talk about food for the next several weeks. I'm very excited about the science of food. And I started looking into eggs, and I realized there's so many cool things you can do with eggs. So today we're going to talk about engineering eggs, you know, the structural properties of eggs and stuff. And next week we're going to actually bring a frying pan and make some food.
Oh, all right.
We're going to do some cooking.
We're actually letting you around a flame.
Right. So first of all, we want to be able to tell the difference between a hard-boiled egg and a fresh egg, because I don't want you to think I'm cheating in what I'm about to do next. Okay, so the way you can tell them apart is if you put the egg on the table.
So by putting a smiley face on
and you spin it, and it kind of flops over right away, then it's going to be raw. If you spin it and it goes like a top, then it's going to be hard-boiled. So this must be the raw egg, so I'm going to toss it up. You're going to catch it in the bowl.
Okay, I'm going to pull my sleeve back.
No, you're going to hold the bowl.
Okay, oh, just catch it in the bowl.
Yeah. Okay, so that was a raw egg. And so we have this impression that eggs are really fragile things because they tend to break pretty easily, but actually, under the right circumstances, they're very, very tough.
Okay.
Okay, and so in fact, if I just give you a raw egg, in fact, we know this one's, no, that one was raw. Let's see, this one's raw, okay? So is this one. If I give you a raw egg and I just ask you to squeeze it, to break it like that, you won't be able to do it.
Really?
And just because I don't want you to be too scared to push hard, I'm going to put it in a baggie here, okay? And so if you just hold it sort of end to end and squeeze it as hard as you can.
Okay, on the ends?
Yeah, on the ends.
I can't do it.
It doesn't break, does it? It's tough. It's very tough. In fact, even just holding it in your hand like this and squeezing it it's very, very tough. Okay? This eggshell is very hard stuff, and it's very good at distributing the force that you put onto the ends. And if you squeeze on the egg from top to bottom, the forces are kind of distributed around and go down, and the egg is very good at not crushing when it's pushed in. It doesn't have a lot of strength for things from the inside trying to get out. So the little chick can hook its way out with its little beak. Yeah. So there's something else you can do with an egg to sort of demonstrate this. This is kind of fun. So I've got a raw egg here and a little skewer. If I just make a hole through this thing like this, okay, then I can sort of lobotomize it a little bit like that, and then I can blow the inside out.
Oh my gosh.
Oh, I think I just broke it actually. So I did that before we came in, and I have 3 sort of halves of eggs here. Okay. And I have this heavy box with a lamp in it that I found in your back room.
Okay.
And these, you know, this would look really fragile, doesn't it? But I can put this thing on here, and it doesn't crush them.
And this is holding one of our lights, so
that's right.
Garden lights are pretty heavy stuff.
So even now, even when the egg is broken and cut with scissors, and what I did was I just took the egg that you just saw. Okay, eggshells are surprisingly kind of rubbery. Well,
you have a hole on the side.
Yeah.
Okay.
Okay, and I just cut it with a scissor and cut it in half. Okay, you can do that yourself at home. Okay, I would cut it around the other direction, and then you can do this little experiment, and you can actually pile quite a few books on top of these halves of eggs.
So resilient no matter how you cut it. What are we going to be talking about in 30 minutes?
Okay, in 30 minutes we're going to come back and we're going to talk about what the eggshell, because I have some eggs without shells that aren't broken yet.
Right.
And we're going to talk a little bit more about what the gooey stuff on the inside is made of.
Interesting. All right, Matt Stellan, our wise guy, here talking about the physics of eggs. Thanks for being here. It is 6:53, so we're going to check in with the meteorologist, or excuse me, with Alexander Harold, who's in for meteorologist Robert Reese this morning.